Okay, something idea. Okay, to achieve this goal, I think it is necessary to understand how the Linux kernel is compiled. Apparently, this topic is not quite for the Zen guys. But as I know, 1 year ago, kconfig is ported to Zen. And on the other hand, I think it is it may be helpful. On the other hand, getting familiar with Kbuild can help people to understand how GNU Make to manage a big project. So that is why I'm here. Okay, this is an outline, and I will introduce kconfig and Kbuild, and then dive into Kbuild. And we will focus on how the vmlinux file and bzImage file is generated. And then we will see the current status and update. Okay, first, the introduction of Kbuild. I don't see an official definition of it, so I think a brief definition may be like this. It is a build framework based on GNU Make and a standard set of cross-platform tools designed for Linux. And from my understanding, I think Kbuild can be seen as a set of routines or utility written by makefile language, even if makefile is not a programming language, I think. And it also involves a configuration framework called kconfig. So I think anybody who has Linux experience should know these two tools. Kbuild is a powerful build system. It is highly modular and customizable. Anyone who has Linux kernel experience may feel that it is friendly to the developer. And this is achieved by the kconfig, who introduce an abstract layer. And this also means it would be easy to extend it with new feature. This build system make Linux probably the most, probably is the only OS that has a unified code base. In contrast, for example, as I know, Microsoft and Apple, they use different code base for their desktop OS and mobile OS. But Linux, from supercomputer to embedded device, the same code base. Since the advent of the Kbuild system, many other open source projects readily adopted this cool build system like that. Okay, I think people can benefit a lot by understanding Kbuild. The first one is also the most important one, I think, is you can acquire the perspective of God. That means your site will not be limited by your working area. You will get a system level view. And you also will get deep understanding how makefile manage a large project. And you won't be scared when you see compilation errors. And you will know the relationship between the vmlinux and the bzImage file of Linux. And the last one is it can help to understand the boot process of Linux kernel, which is why I care about it. Okay, the first step of building a kernel is to do the configuration, but you can skip this step in then. I will explain why later. Kconfig provides many config targets, as shown in this picture. But I bet makefiles is the most popular one. Among these config targets, most aims for creating a .config file, while a few others don't. Like save def config or list new config. They don't create the .config file. And by the way, to the audience who knows Linux well, a few months ago, there was one config target named silent old config in this list, but now it's renamed and dropped from the list because the name actually doesn't do what it tells. And it is for Kbuild internal use. Okay, now let's see how the .config file is generated. This picture shows a typical process for most config targets, but not all. Like all yes config, all no config, they have slight differences. The config targets are actually processed by different host programs. And some targets may have a GUI frontend like makefiles, and some don't, just come online. Okay, wait, what is host program? It is one of the build targets during the kernel build. It is actually a user space application. It is ordinary. It is just provided by Linux kernel itself. Like I just said, most config targets don't have GUI, which means the host program conf in the top will deal with most config targets. That is why I split it a little far from the others. At first, they will read the kconfig file under the Linux source root to construct what I call the initial configuration database. Then, if you are not using make def config, it will read an existent config file according to this priority, the green one, to update the initial database. And then, if you are customizing with the GUI or command line, the database will be updated again. And at last, the updated database will be dumped into the .config file while the write function. So that's a typical process of the generation. Okay, among these config targets, a few of them are different from others. So let's take a look. The first example, if you want to use the architecture default configuration, then make def config can help you. Almost every architecture provides default configuration under that directory arc configs. Some architecture may provide not just one, maybe a few. But only one is used by this architecture, which is specified in the makefile. The second example, and sometimes people may want to see their own configuration as a default one. Then you should do this here, but not do that. The right way is you use make save def config, and it will generate a file called def config under the source root, and then you copy this def config file to here, to this path, use this name, and then you can use it by make this config name. Please note, in Linux kernel, this config name must be ended with this string. And the wrong way is just copy the .config file to that path. Actually, the result of the wrong way is not wrong. It's just not the right way. Why? And in fact, no matter the generated dev config or the default ones under the architecture directory, they just see the differences. What does that mean? All configuration item has a default value. This default config file just sees the items which have the value different from the default. So contrast to the .config file, this generated file, the generated dev config file will be quite short because the .config file has all the configuration item as its content. Okay, this is another important config target I think people should would better know. It is a special one. It was just like I said, it was named silent old config, but now renamed to thin config. It doesn't generate a .config file, but process the .config file as input and output many other files. Now let's see what files it generates. auto.conf, traced.conf. These two .conf files are simplified configuration, which don't have the node value item, and they are used in the makefile text processing. For example, I think maybe most of you will be familiar with this example. And the autoconf header file, you know, it's a .h file. It's actually using the C language file. And it also there are many empty header file here in this path. This is actually a trick Kernel played to do the configuration dependency tracking, which means when a configuration item is updated, the target which depend on it should be updated too. It needs a host program called fixstep to set up the dependency relationship. This is the source file of this too. By processing the .d file to output this .cmd file, the rationale is each empty header file corresponds to a configuration item. When the corresponding header file is updated, when the corresponding configuration item is updated, with the help of the fixstep tool. The tool adds the empty header file to the prerequisite of the target. Then things are done. I will show some details later. Okay, now I will introduce some config things in Zen. Actually, I don't have Zen experience before. A month ago, I spent 2 weeks digging in Zen to see how keyconfig works in Zen. So now I will share with you what I found in these 2 weeks. but I bet you guys may be more familiar than me. So if I'm wrong, please correct me. Kconfig is ported from Linux to Zen about at the end of the 2015, because Kconfig actually interfaces with Kbuild. So when lifted up, it's necessary to do some modification. So let's take a look at the differences. It drops some unnecessary things like config targets, like module support. As you know, Linux support module. And it needs some adaptive work, like it lifts up some necessary variable from the Kbuild to support the kconfig work process. And it actually don't have any configuration dependency tracking. Even it also generated that empty header file. And you don't need to do configuration explicitly, but just go with make. Because actually, it will do the make dev config in the make file for you by default. And the last two things is some nitpick, I think. As I tested the kconfig in Zen, I found the config host program is always recompiled. And the config target, safe dev config, actually don't work. That means you can't make your config file name. Okay, the usage is the usage introduction. The first usage is documented in Zen. I think most of you will know, but I'm not sure if you all know the second example. Does anyone don't know the second example?
I don't know.
Okay, thank you. Okay, so that make me think this slide makes sense for you as its value. The second one, with the config expert, you will see more configuration option. As a commit message that the purpose of config expert configuration option is to make some non-standard kconfig options visible during the configuration process. The config expert option is not itself visible during the kconfig configuration process. So typical users will never see it, nor any of the non-standard configuration options. Actually, I don't know what is non-standard options thing. Okay, now we move to the main topic of today, Kbuild. If you want to understand Kbuild, learn makefile at first, of course. And how to learn it? I would say just read the author document via info make. For the most audience who speak Chinese, I guess you all know a very famous electrical book called 跟我一起写 makefile. 大家都知道 Okay, everybody knows. The electric book basically translated the officer document and does some reorganization. It is not bad, but I think it is just suitable for newcomers who never heard of makefile to get an impression of it. But to get an comprehensive and accurate knowledge of makefile, the best way is to read the officer document. And after reading it, I feel it is not that hard for Chinese people. I think maybe 80% is easy to read. Essentially, makefile language is easy because except the concept of rule, that one, Most of the statements are text processing and variable assignment. But there are too many ways to do this, which makes the makefile a little bit harder to read. Okay. This is what I wrote looks like, and the make utility will automatically determine which piece of the large program need to be recompiled and issue the commands to recompile them. There are many terms you should know to understand Kbuild. This is just part of the list. My personal suggestion is go through the first section, sections of the author document to get an impression of it, then consult it when necessary. Okay, when we talking about Kbuild, we actually refer to a lot of makefiles. The top makefile is the entry which resides under the source root. The architecture makefile is the supplement of a full specific architecture. And .config, you already know it. And some makefiles under the scripts directory has some common rules defined for the whole Kbuild. And some others are targeted for special purpose, like building a GCC plugin. And the last one, Kbuild makefiles are the ones under each component. In charge of building the corresponding component. There are many targets need to be built during kernel building. We will just focus on the vmlinux file and the bzImage file, which is just kernel itself. Okay. Large software projects are usually simplified by dividing them into major components, often collected into distinct programs, libraries, or books. These components are often stored under their own directory and managed by their own makefiles. One way to build an entire system of components employs a top-level makefile that invokes the makefile for each component in the proper order. This approach is called recursive make. Because the top-level makefile invokes make recursively on each component's makefile. A recursive make is a common technique for handling component-wise build. So does Linux kernel, and also Zen. So let's take a look at the picture here. I drew this picture about half years ago, but unfortunately I lost the draft. So because Kbuild is still under active development, so there should be some update to this picture. There actually is one more called Kbuild vmlinux libs, which indicate all the libraries. And the building.o file now is building.a file. Every component dwells in its own directory, and all the object file that finally goes into the Linux kernel will goes into its own built-in file. This is an intermediate file. Then all these components will be collected into the vmlinux file under the source root. You see, every component finally goes into the vmlinux. It looks not hard, but it's not that simple to achieve the goal. It involves many details. see some makefile code. Actually, I'm reluctant to explain code in a talk, but for this case, I think it is a little hard to explain it with plain words. So I just picked some white code here to show the process. Makefile actually constructs a dependency chain or tree from a certain view. Like this picture I draw, it is a dependency tree, actually, I think. Now let's go and see the code to understand how the vmlinux is produced. All the object files that goes into the vmlinux are indicated by this variable, vmlinux steps. As you can see, there are many level variable assignment. The first one, this is the first level assignment, and the second level, and then the third level. The third level will consist of some concrete file. The third level variables are processed and transformed to the corresponding building.b file. This is the transformation. Then a rules here set up the dependency between vmlinux depths and the vmlinux directories.
This is your code next, right?
And the variable vmlinux directories holds the directory part of each built-in.a. Then apply this rule, got it? And actually, this is the entry of the recursive make. And the expanded recipe looks like this. This is the expanded recipe.
Just half of the slides.
I mean, it's between you two, so how much do you need?
Well, I mean, it's whether it's item, so 10 minutes a week.
10 minutes?
Well, I mean, my slides are also quite long, so it's. I mean, I'm not. If I don't give the talk, I mean, I don't care, but I think other people might. So.
Yeah.
Okay. Now I'm trying fast to.
So try to do it in 5, and then we'll slip the next one a little bit into the break,
okay.
right? And then if you guys have questions, you can come. You're probably here until lunch at least, right?
Yes.
Yeah. Okay. So then 20 minutes. Sorry.
I'll try to speed up. Okay. I'm not sure I'm going to explain this code here. Okay. Okay, I will speak up. Now we know how recursive make happens. So let's just take an example of the init directory to show how the building.a file is generated. As the recipe shows, the rest work will goes into the makefile build. It includes several other makefiles which marked as red here. And in this example, the Kbuild makefile means the makefile of the init directory here. Maybe I think I should skip this slide because of the time, and you can go to me if you want to know the details. Okay, and one thing I think I should mention, the compilation flags management in Linux kernel Kbuild is part of the hierarchy of flags, which has a global flag at the top, and it applies for every compilation target. And each component directory will have its own flags, like the second and third ones. And finally, each target can add or drop certain flags by these two variables. Okay, in this picture is quite important, I think. So I was planning to give a detailed introduction, but now, the time. This is how the vmlinux file is finally produced. It is via a script called the red one. It wouldn't bother a script to do these things if only linkage is done. So there's more things to do in the script. And this is a whole process of how process the vmlinux file of under the source root, then finally produce the bzImage. And this picture shows the whole process, but I will skip the explanation. Okay, this memory image of the bzImage. Okay, this simple introduction of how module is produced. I don't want to repeat the word here. There's one thing for your information. There's one more .c file created for each module. And if you want to know the details, please go dig into this makefile. Okay, this is actually another thing I think is worth to mention. The dependency tracking. Linux kernel Kbuild tracks several dependencies. The first one is the most common one. I call it the inter-file dependency. And the second one is a configuration dependency. I already mentioned a little in the previous slides. The last one is a command line tracking. It means if the command line for one target is changed, the target should be updated again. Also, I will skip the details here because of the time. Okay, also the details. Okay, this is the latest maintainer of Kbuild. He became the maintainer since last year, and before his join, Kbuild is very stable for many years, as I learned. After he joined after he's the maintainer, I made a lot of improvements and fixes to Kbuild. He's a very productive man. So now the porter of the key config of Vim, a dog, has more things to do. Okay. So since the new maintainer comes, there are a lot of improvements. For example, numerous cleanup. I also post dozens of cleanup patches to Kbuild, and then some fixes to compatibility to the new compiler plan. And I just mentioned the building.o file is now renamed to building.a, which means the archive. And the most important one, I think, is the performance optimization. For example, there is a compiler flags test in the during the build, but now it moves the. Sorry.
Try to close slowly. I don't George can.
Yeah, it's 5 minutes. Okay. Okay. You can go to me if you want to know some more.